Okay, can everybody hear me? Yes, no, maybe? Excellent. Thank you. Well, yeah, hopefully. Okay, so we're going to talk not about all of Newton's laws. We're just going to kind of talk about his first one and just a little bit from his second law, but it's sort of related. You can't get away from them. Okay, so our objectives. We're going to learn about inertia, which you guys already know a little bit about, or maybe a lot, and about balanced and unbalanced forces. Now, the one thing that you should know is that Newton's first law is really just dealing with balanced forces. The unbalanced forces come into play whenever there's acceleration, and that's going to be Newton's second law. But we'll talk a little bit about it. So, Newton's contributions. Newton developed physics, but then he developed calculus to explain the physics. We don't go into calculus physics, types physics, but there's math in physics. And these are some of the other things. His laws of motions are the things that we're studying right now, and his theory of gravitation. All right, and the telescope. Do you guys ever look at the stars? Okay, so Newton's first law, it's the law of inertia. And what it says is that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So if you give something a push and there is nothing to stop it, meaning that there's no friction, like on a table when you push a book, or when you're driving in a car, there's no friction between the wheels in the road, there's no friction between the on the brakes, then something will just keep on going forever, just a little push. And that initial push is actually an unbalanced force to get it started. All right.
Like they say on the commercials for some blood pressure stuff. It's,
oh yeah.
Or like their blood insert or whatever. Object in motion stays in motion.
There you go. Watching television, you'll learn all about Newton's first law.
Only because of commercials.
Okay. So a balanced force, if you have two forces that are acting on something and they are the same, but their action is in opposite directions, then that will produce no motion. So if I were pushing on my computer, but somebody was pushing back on it, and we have the same amount of force, done.
Kind of like the sticky things on the bottom. You can't really push it.
Yeah, the sticky things on the bottom. That's a good example. However, unbalanced forces mean that unequal opposing forces produce an unbalanced force causing motion. And I thought I fixed this, but you can't really see it. Okay, so here's this truck. It's being pushed from the back with 100 newtons of force and pushed from the front, okay, with 60 newtons. So it's going to move in the direction of the bigger force. So you guys write in the chat box, or everyone that I see here, tell me which way is this going to move and what's the force that's going to propel it forward. It's going to go forward, and it's the bigger force, that force that's pushing it forward. By how much? What's that force going to be that's pushing it forward once you do your little addition and subtraction, whatever it is? Yes. Okay. Hi, guys. Okay, so if an object in motion tends to stay in motion, why don't things keep going on forever? Let's type this in. What do you think? Why don't things keep going on forever and ever? Easy question. could be. An unbalanced force is going to stop it, but I guess what I'm trying to get out of you guys is what is that unbalanced force called?
Friction.
Yeah, exactly. Yes, Tay said friction too, and it is friction. So they don't keep moving on because of an unbalanced force. A book sliding across the table slows down because of friction. Oops, I went the wrong way. Okay, what if you throw the ball up in the air? One of you guys was saying, oh, Jamie said gravity. And yeah, if you throw a ball up in the air, it actually changes direction. If you guys remember from those graphs that we did, it'll go up as far as it, for whatever force you threw, and then it, because of gravity, it's pulling it back down. It's coming back down. It's changing direction. Okay, so this is important. Mass is a measure of the amount of matter in the object. You do not, if someone says, how much do you weigh? Weight is a combination of mass and gravity, all right? And it's measured in kilograms, but mass is just, I don't know, if you took, somebody give me their weight. 144. Okay, so someone weighs 144. William, you weigh 220. What I want you to do is divide that by 32.2 because you're talking about pounds. So if you have a calculator, you can do this. I don't have one with me. But if you divide that by 32.2, which is gravity in feet per second, then you're going to get your mass. So does that make sense? You are a weight, but if you divide by gravity, that's your mass. So inertia is a property of an object that describes how what? Describes what? We're going to fill in the blank here.
Movement.
How something, the motion of an object.
Position.
Okay, this one is kind of hard. I couldn't figure this one out, so it's a little bit difficult. We got movement, we got, okay. How much it resists change. Does that make sense? Inertia is the property of how much of an object.
When you're trying to force it, could do something.
Kind of.
They're just like, no.
That's right.
Like when you try and force a little kid to eat, no.
Yeah, their inertia says, get away from me. How much it's going to resist change to the motion of the object, all right? So that's inertia. All right, more what means more what? More mass means more, hold on, there we go, inertia, exactly. Excellent. All right, so that first one, it was a little hard, that fill in the blank. I couldn't figure that one out. All right, so does that make sense? We know all about inertia now. We know about mass. Mass is not a weight. That's really important. And that's where, when you think about your units, when you assign units to something, you really need to assign those units so you know if you're talking about weight or mass. Okay, so the first law says unless acted upon by an unbalanced force, this golf ball would sit on this tee forever. But what is the unbalanced force that's making it move? The club. You're swinging that club.
Somebody.
Or yeah, I guess.
Or the wind. The
wind.
From when the club swings and it falls off and you go like.
That could be too.
I'm back on there.
Yeah, I'm not a golfer, so I would probably whiff it off with my wind. Okay, so what is the unbalanced force that acts upon an object in motion? You guys already said that. It's friction. The important thing to know about friction is that there are 4 types of friction. We're not going to go into all of them. We will as we go through the course, but these are the type of friction. Sliding friction. And think about that like when you're on a really smooth surface, ice skating, ice. That's where you get sliding friction. Rolling friction is like bowling. Fluid friction is either air or
What
liquid.
about riding a bike or skateboarding or
That would be static
rollerblading?
friction.
Why wouldn't it be rolling?
What about driving a car? Are they going down a hill putting it in neutral?
Boy, you're just asking so many questions. Didn't think that anybody would ask questions.
You
Good
have to-
question.
You have to test the teacher.
Yes, well, you're doing that very well. Actually, I would say it's rolling, although I've always called it static. But now when you talk about it, I guess when you bring it up, it is rolling friction. So these guys are talking about cars and bikes and the friction between the road and the tires. That's really going to be rolling friction. Hey, you guys, all right. Extra credit. All right, so once your ball is airborne when you're golfing, unless acted upon by an unbalanced force, and in this particular case, it's going to be gravity pulling it down, or
Kinetic energy.
can you get a what?
Kinetic energy.
Oh, kinetic energy. Whoa, you're like way ahead, girl.
Oh,
All right,
I think I had to do with kinetic and potential energy like years ago.
Yeah,
All this
the
is-
freshman year.
So that's why it's,
could be
that's why I've
physical
been
science.
zooming through pretty much all
Yeah,
this.
nice.
It's pretty easy. But it's good to learn stuff second time because
Now I'm going to have to make it harder.
just in case.
Okay, so an unbalanced force,
I'll
either
make it easier for
gravity,
you guys.
or air or fluid friction. It's never going to stop, okay? So, and if you think about it, if there's some kind of wind blowing against your ball, it doesn't go as far,
Or it rolls in a different direction.
rolls in a different direction,
Or it keeps going
because,
further.
well, that would be gravity, like when it, however it lands, and if it rolls down the hill, that would be the gravity. So, this, I like this, but this is inertia. And can you guys sort of write, it's, you know, not a whole paragraph or anything, but what's going on? Why is the guy flying out? Why isn't the brick wall falling down? Why isn't the car, you know, going through the brick wall? Give me some ideas about what inertia has to do with this picture. As you're typing, when you think about inertia, remember, more mass means more inertia. So more resistance to change. Okay, good, William. The guy isn't wearing a seatbelt, so actually that seatbelt tends to keep him in place, right? Okay, think about it. How massive is the car? How massive is that brick wall? And how massive is that guy that's flying through the air? Yes, Katie Beth, good. So the wall is really, really massive. So it is really resistant to change, and that's why it's not fallen over. The car is also really massive, and that's why it's not going through the wall. It's stopping.